Hi everyone, today we're going to talk about how can we combine various concepts to make valid conclusions. So take a look at this do now question. I'll give you a moment, pause the video and see if you can answer it. Alright, so it says do now. ED is an altitude in triangle AEC. Okay, so I'm going to mark that. Altitudes form right angles, so that's how I mark it in the picture. And ABCD is a straight line segment. Explain why angle ECD, so I'll mark it over here, is definitely obtuse. Well, if you focus on the triangle EBC, right, we know all the angles in triangle EBC have to sum to 180, and you already have 90. So if you take off the 90 that you have, you're left with 90 degrees. Angle E and angle C have to split that 90, which means angle E and angle C are both going to be acute angles. Let's just give them numbers, any number. I'm going to make them 30 and 60. The angle next to this angle ECB, has to be a supplement because it has to make a 180 because I have the straight line there. So that means this angle would be 120, which means it's obtuse. Even if I made this angle 89 degrees, this angle would still be obtuse. It'd be 91 because, again, it has to sum to 180. So no matter what, angle ECD will have to be obtuse. Hopefully you got that right. Okay, so we're going to talk about two types of reasoning. The first type of reasoning is called inductive. So inductive is when you look for patterns, and then from the patterns you make conclusions. So a really good example of this is when people take polls and they ask people, hey, who are you voting for in the election? And then from that data, they make these statements like, if you live in an urban area, they're more likely to vote for this candidate or that candidate. The problem with this is that it's not true for everybody. I'm sure you guys know people who live in the same neighborhood as you, but are voting for somebody different than maybe you would vote for. The problem is these patterns don't necessarily use facts. Another example, look at this list of prime numbers, 3, 5, 7, 11, 13, and 17. A student made a conclusion and said, oh, if a number's odd, then it's prime. Anyone see any issues with that? Problem is, there's a lot of odd numbers that aren't prime. Another problem, 2 is prime, and that's not odd. So that's what we call a counter example. When you can find an example that is against what you said, that's called a counter example. Okay? So 2 works because it's prime, but it's not odd. 9 is odd, but it's not prime, right? So another example that would disprove this would be 9. So you guys can kind of see already that inductive reasoning has problems, right? Patterns don't always lead to facts. It's a really good thing in geometry we don't use inductive reasoning. We use what's called deductive reasoning, which we'll get to in a minute. Another thing to keep in mind, the conclusion that you make with inductive reasoning is called a conjecture, okay? So that statement that we just made about those odd numbers being prime is a conjecture. And to prove that a conjecture is true, you have to prove it's true for every single possible number that exists or every possible scenario that exists. Sounds like a lot of things to prove, right? It is also very easy to disprove a conjecture because all you have to do is find one thing that makes it false. So going back to our prime example, because 2 is even and prime, I disproved that conjecture very simply. It's very hard to prove conjectures, but it's pretty easy to disprove them because all you need is one counterexample. So again, going back to this idea of deductive reasoning, which is what we use in geometry to make proofs and stuff, we use facts and rules and logic. Things have to be true in order to use them. Not patterns, not something, we think it's true. No, it has to be a fact, okay? So we use facts, we use rules, and we use logic to make conclusions in deductive reasoning, okay? So a simple example of deductive reasoning, given, if a car is out of gas, then it will not start. I think we all could agree with that, right? So if I tell you Sarah's car is out of gas, what can you conclude? What do you guys think? Hopefully you said, well, her car is not going to start because that's a fact, okay? That's what deductive reasoning looks like. Okay, so by definition, geometry is the branch of mathematics that is based on deductive reasoning. Most people think geometry is the study of shapes. That is not true, okay? Geometry is the branch of mathematics that's based on deductive reasoning. So basically we use definitions, which you guys know what definitions are. The how something's defined. We use some things called the undefined terms, like a point, a line, a plane, and postulates or axioms, and then we use logic to build on everything else. All a postulate is something that we accept to be true without proving it. So, for example, real number properties that you've learned in the past, like commutative, associative, those are postulates. We don't need to prove them, we just accept them to be true. Theorems are a statement that is proved by deductive reasoning. So, for example, any two triangles with three congruent sides to one another are said to be congruent triangles. Okay, that's a theorem. We're going to learn a lot of theorems, and you can technically prove all of them. We just don't prove all of them because they take a long time sometimes. But just know that all a theorem is something that we could actually prove if we wanted to. Something to keep in mind, many of the rules of geometry are theorems because they are not true because someone said so, but because we can prove it. So I hate when kids tell me, oh, well, my teacher told me it, so that's why it's true. No, it's true because you could actually show it or prove it, and that's just something you want to keep in mind when we move into proof. So let's look at some practice examples. Take a moment, look at this conclusion, and decide why it's not valid. So, given that it's a quadrilateral, can I say that angle M is a right angle? Hopefully you realize it's not valid because I don't know what type of quadrilateral this is. Not every quadrilateral has right angles. I know it looks like a square, and we know squares have right angles, but it could be a parallelogram. So you never want to look at the picture and make an assumption. Number 2, if ON is extended to point P, so something like this, then angle M is equal to angle MNP. Can I assume that? No. That would be what we call alternate interior angles, but I would have to know that I have parallel sides, which they did not tell me. So those things are not valid because I don't know enough about this quadrilateral. I don't know it has right angles, and I don't know it has parallel sides. So that's why I cannot make those conclusions. It's very important that you understand that just because something looks a certain way doesn't mean it's necessarily true. You have to actually be told it in order for it to be true. So this is a good exercise with this. Look at the pictures. What can you assume? Let's start with the first one. Take a moment. What can you assume just by looking at that picture? So I think what people want to say is, oh, T is the midpoint. That is not an assumption. If I want to say that T is the midpoint, I have to know it's a fact. I don't know that. They didn't tell me it. I can't assume it. So what can you assume looking at this first picture? The only thing you can assume is that T is between A and M. That's it. That's all you can assume. You could also say AT plus TM equals AM. But you cannot assume that T is the midpoint. I know it looks like it, but you cannot assume it. What about the second picture? What do you guys think we can assume there? Well, I can say that angle LHC is congruent to angle NHU because they're vertical angles. Similarly, I could say angle CHN is congruent to angle LHU, also because they're vertical angles. I could also say angle LHC plus angle CHN equals 180. And I could do that many other times too. I could say the angle CHN and angle NHU, or NHU and UHL. There's a bunch of 180s there. Those are assumptions though, just by looking at the picture. Take a moment, see if you can come up with a conclusion for these givens, and then your justification will be the reason why you can say these conclusions. So pause the video and see if you can come up with some conclusions and some justifications. So for the first one, if I know that E is the midpoint of BD, I'm going to draw myself a little picture just so I have a visual. So again, they told me it. It's a fact. What can I conclude? Well, midpoints, by definition, cut a line segment into two congruent pieces. So my conclusion could be BE is congruent to ED. And my justification? A midpoint cuts a line segment into two congruent pieces. See? You're already writing proofs and you don't even know it. Second one here. Given, what can you conclude? So there's definitely more than one answer here, but I'm going to say angle 6 plus angle 5 equals 180. And my justification, I'm going to say two angles that form a straight angle sum to 180. And you could probably word that in a couple different ways. Last practice question here. A lot of givens, write as many conclusions as you can from the given information. Take a moment, mark up the picture for yourself, see if you can come up with a couple different conclusions. There's quite a few. So I'm going to start by marking up my picture. Hopefully you did the same. Hopefully you're starting to realize that marking things up really helps. So BG is the altitude of triangle. Oh, my A is cut off. My apologies there. A should be there. Of triangle ABC. So altitudes form right angles. So that's one conclusion I can make. Angle AGB and angle CGB are right angles. Okay. DH is a median of ADC. So a median's job is to cut something into two congruent pieces and to kind of form the midpoint. So I'm going to say ADC. AD is congruent to DC. I can also say H is a midpoint of ADC, of AHC, the line segment. Okay. Next given, AC bisects angle BCD. So BCD. So a bisector cuts an angle into two congruent pieces. So angle BCA is congruent to angle DCA, right? The bisector. A lot of givens here. I'm running out of colors. EP is perpendicular to AC. So again, I'm going to have right angles at P. So angle APE and angle EPC are right angles. Guys, tired of writing givens and conclusions? AD is congruent to DC. BEF and C are collinear, and AB is parallel to DC. Whew. There's a lot more things you can say, guys. You can also say the right angles are congruent. You can say that if you have parallel lines, you have alternate interior angles, corresponding angles. You can even go as far to start to say that you have congruent triangles if you see them. But I think we have enough conclusions for now. So hopefully you found this idea of making conclusions not so bad. And we're going to be building on this as we move forward in these proof lessons.